Welcome viewers. In this video we'll see the solved problem based on the RC series circuit. Resistor and capacitor is connected in series. Based on that we'll see the problem. So part 2. Part 1 already available in separate video. The link is available in the description box. Now we'll go to the first problem. A capacitor and resistor are connected in series to a AC supply of voltage 60 voltage 50 Hz. The current is 2 ampere. The power dissipated in the resistor is 80 watts. The capacitor and resistor connected in series with this supply voltage. The current is 2 ampere, power dissipated 80 watts. We need to find the impedance of the circuit, the value of resistance, capacitance and power factor. We need to find this parameter. So the given data is voltage is 60 volt, frequency is 50 Hz, current is 2 ampere and power dissipated in the resistor is 80 watts. First we will find the impedance. Impedance Z equal to V by I. Magnitude of Z equal to magnitude of V divided by magnitude of I. So 60 divided by 2. Voltage and current is available. 60 divided by 2, 30 ohm. Now one more data, we will find the resistor value. The power is given. Power dissipated in the resistor is given. So power P equal to I square R. So from that R equal to P divided by I square. The P is given 80 watts and I is 2 ampere. So 80 divided by 2 square, 80 divided by 4 is 20 ohm. So the resistor value is 20 ohm. Now we will find the capacitor's value. So first we will find the impedance. Z square equal to R square plus Xc square. From the impedance triangle we can found this relation. So what we need is Xc square. So Xc square equal to Z square minus R square. By taking square root on both the side, Xc equal to square root of Z square minus R square. Now we will substitute the value. The Z is 30 ohm we calculated. R is 20 ohm, that also we calculated. So by simplifying this we got 22.36 ohm. Now we got the capacitive reactance. For capacitive reactance one more formula is there, Xc equal to 1 divided by 2 pi Fc. So from that we can rearrange this X and Xc. So that C equal to 1 divided by 2 pi into Xc. So because we need to find the capacitor value. So C equal to 1 divided by 2 into pi into the frequency is 50 Hz. The Xc we calculated as 22.36. So by simplifying this we got 142 into 10 to the power minus 6 farad. This minus 6 can be written as microfarad. So C equal to 142 microfarad. Now we got the capacitance value also. Now we will find the power factor. Power factor, the formula available R by Z from the power triangle. From the impedance triangle we can easily find cos phi equal to R by Z. The R is 20 and Z is 30, we already calculated. So 20 divided by 30, 0.67. Leading. Because of capacitive circuit is given leading. In capacitive circuit the current is lead the applied voltage. So that this power factor is 0.67 leading. Now we calculated all the parameters. We will go to the second problem. A metal filament lamp rated at 750 watts 100 voltage is connected to series with a capacitor across a 230 volt 60 Hz supply. Calculate the capacitance required and power factor. We need to find what is the capacitor value and also what is the power factor. So the lamp is 750 watts with a voltage is 100 voltage. The supply voltage is 230 voltage 60 Hz. Now we will find the capacitor value. So from the given data first we will find the power. Power P equal to I square R or VR into I. So the power value is given. So from that I equal to P divided by VR. Power dissipated in the lamp is 750 watts. So based on that we can use this formula P equal to VR into I. So that I equal to P divided by VR. So the power dissipated is 750. The voltage across the resistor is 100. So these two are given 750 and 100. So that 750 divided by 100 is 7.5 ampere. So current flowing through the circuit is 7.5 ampere. Because of series circuit, same current is flowing through resistor as well as capacitor. So from the power dissipated and voltage across the resistor, we calculated the current value. So this is a series circuit, so that total voltage equal to voltage across resistor plus voltage across the capacitor, that is V square equal to VR square plus VC square. So we need VC square, that is equal to V square minus VR square. This it is interchanged. By taking square root, VC equal to square root of V square minus VR square. The V is nothing but 230 voltage. The supply voltage is 230 voltage. The voltage across the resistor is 100 voltage, that is given. So by simplifying that, we got VC equal to 207 voltage. It's not a watt, it's a voltage. 207 voltage. Now we calculated the voltage across the capacitor also. Now we'll go to the next step. Now we'll find the capacitive reactance Xc equal to Vc by I. The one formula is available, Xc equal to Vc by I, R equal to V by I, like that. So Vc, voltage across the capacitor, is 207. Just now we calculated. The current is 7.5 ampere. So 207 divided by 7.5, 27.6 ohm. So the capacitive reactance is 27.6 ohm. For capacitive reaction, one more formula is Xc equal to 1 divided by 2 pi Fc. So what we need is C. So exchange these two. So C equal to 1 divided by 2 pi F into Xc. Now we substitute all the value. 2 into pi into the frequency is 60 Hz. The Xc value what we calculated is 27.6. So by simplifying this, what we got, 96.19 into 10 to the power minus 6 farad. So this 10 to the power minus 6 can be written as microfarad. So 96.19 microfarad. So now we calculated the capacitor value. Now we'll go to the power factor. Power factor cos pi. Power factor is nothing but cos pi, that is equal to R divided by Z. From the impedance triangle we can found this relation. So first we will find the Z value. R value is known. R value already given. But Z value we need to find. Z is nothing but V divided by I. V is 230 divided by 7.5. I 7.5, that is 30.75 ohm. Right. So when you calculate, now we calculated the impedance value, that is 37.5 ohm. 30.7 ohm. So the power is given, W equal to I square R. From that, R equal to W by I square. So 750 divided by 7 point square, it is 13.33 ohm. So the R value is 13.33 ohm. Right. So the power factor is cos pi equal to R by Z. First we calculated the Z value, impedance. From the power given, power dissipated in the resistor is given 750 watt. By using that, we calculated the R value also. Now we can calculate the cos pi. Cos pi equal to R divided by Z. R is 13.33. Just now we calculated. Then Z 30.7 impedance. So by simplifying, what we got, 0.434 leading. Because of capacitive circuit, the current is leading the voltage, so it is given as leading. So the cos phi power factor is 0.434 leading. Now we calculated all the values, capacitor as well as the power factor. So in this problem we discussed the solved problem based on the RC series circuit. Thank you.